You in previous class about the contour integration, and we have done some questions when closed integral fz dz was equal to 2 pi I and sum over residue, right? So we saw that for different contours we applied this, and we got complex integration. Now it's time to apply the concept of complex integration to real integrals. Okay, we have to apply the concept of contour integration, which is complex integration, to real integrals, because until unless we can solve the problems related to real integrals, जब तक हम real integrations को नहीं solve कर पाते, तब तक the complex integration will not have got that much of value or that much of importance, because in our situation, when we are solving say some Schrodinger equation or some scattering problem, we encounter real integrations. So the issue is ki can we solve that real integrations using complex integration? Okay, so this I will discuss case by case. The first case is that if we have some integrals like this, 0 to 2 pi, some function of cos theta and sin theta d theta. That means if the limit is 0 to 2 pi and you have some function of cos theta or sin theta, then we can handle it using contour integration. B is if we have integrals like this, some minus infinity to plus infinity fx dx. Okay, such integrals also we can handle, and obviously here the function cannot be odd. If it is odd, then answer is 0. C is if we have some function like this, 0 to infinity fx dx, and fx is not an odd function, not an even function like that. Suppose, for example, I must give an example here, like suppose fx is 1 upon 1 plus x to the power 3. Such integrals also I will discuss how to handle them. And fourth one is integrations like this, 0 to infinity log of x or 1 plus x square whole square. I mean integrals involving log, and also integrals involving like 0 to infinity and x to the power, say half, like this. Okay, and in denominator, suppose we have a1 plus x square ka whole square dx, like that. Okay, so power is half. Such integrals. So these integrals are related to branch point and branch cut. Branch point and branch cut. This I will discuss as conclusion of the complex analysis. And these three, let us discuss first of all back to back. How to handle such integrations. And please understand that integrals are always case by case. Integrals, we always go case by case. So like when I say this type of integrations, you can only handle only that particular type of integrations using that particular method. कभी भी ऐसे generalize नहीं करना है कि इसका वाला इसमें लगा दिया या इसका वाला इसमें लगा दिया. You can't do that. Okay, so since you have started doing integrals, you have seen that integrations always go case by case. Okay. ठीक है भाई.
Yes, sir.
Yes, sir.
So let us start from the first one. So it is just like a substitution. जैसे हम substitution पढ़ते थे ना पहले, we used to put something x is equal to tan theta or x is equal to t square in the integration to solve the integrals. So it is just like that. It is just like substitution. So like the first integral is integral 0 to 2 pi some function of cos theta or sin theta and d theta. How to handle such integrations? These are real integrations. Okay. Now the method says, so I am going to transform this into contour integration. Okay. So what I am going to do, I am going to substitute z is equal to 1 into e to the power I theta. I am going to put this. What is this? This is actually mod of z is equal to 1. So this is equation of a unit circle. Equation of a unit circle. What do you mean by unit circle? That means a circle
Of radius 1 unit.
which is like this, and this will be 1, this will be iota, this will be -1, this will be minus iota, circled on the argand plane like this. This is called a unit circle. Okay, centered at origin. So this is we are going to substitute. This is not a general formula. You know the general formula is z minus z naught is equal to r. This is general formula. So that means z minus z naught is equal to r e to the power I theta. So this is a circle centered at z naught with radius capital R. Okay. So now when we substitute this, we will find that 1 by z will be e to the power minus I theta. Z is equal to e to the power I theta. So cos theta sin theta will be 1 by 2 iota z minus 1 by z. Using this definition, and cos theta will be 1 by 2 z plus 1 by z. Right? If you open it using Euler's equation, e to the power I theta will be cos theta plus iota sin theta, and e to the power minus I theta will be cos theta minus iota sin theta. It will go like this. You add and subtract and you will get. So these are the definition only for this particular situation when you have substituted z is equal to e to the power I theta. And also because you have d theta here, that should also be replaced. So how that will be done? So dz will be iota e to the power I theta d theta. So that means d theta will be dz by iota z. So this will be substituted for d theta. So after this substitution, our this integration will be reduced to, will be converted to closed integration C, where C is mod of z is equal to 1 circle, and here fz dz. This we will get, and this we know how to solve. This will be solved using contour integration. This will be solved using contour integration. All right. This will be solved using contour integration. So this is how it goes. So the method is clear to everyone. Those who don't understand should speak more. Those who understand, that is okay. Those who have doubts, they should ask first.
में आ रहा है सर, साइन थीटा इक्वल 1/2 आयोटा जेड माइनस जेड 1/z।
क्या नहीं आ रहा है?
ये सर साइन थीटा इक्वल सर 1/2 आयोटा जेड माइनस 1/z।
ये समझ आ रहा है?
यस।
हम्म।
यस सर।
तो अगर इससे साइन थीटा निकालना हो तो कैसे निकालें? दो इक्वेशन है आपके पास। मैं चाहता हूं कि मैं साइन थीटा की वैल्यू निकाल लूं, तो कैसे निकालूंगा? बोलो भाई।
इसको
इस इक्वे
सब्सट्रैक्ट कर देंगे सर।
बस आपने खुद ही बता दिया अब आंसर। तो जब सब्सट्रैक्ट करोगे तो यहाँ 2i साइन थीटा हो जाएगा, यहाँ z माइनस 1/z हो जाएगा, 2i आके डिवाइड हो
गुड।
जाएगा। एनीथिंग एल्स? ओके। सो बाकी चीजें आ गई सबको समझ में ना? तो अब अगर मैं कोई क्वेश्चन लेता हूं, पहले एक बहुत आसान सा क्वेश्चन करता हूं जिसका आंसर हमें खुद पता भी है पहले से ही, और फिर उसके बाद कुछ ऐसे क्वेश्चंस करेंगे जिसका आंसर नहीं पता। तो सपोज मैं आपसे एक क्वेश्चन पूछता हूं कि इंटीग्रल सपोज 0 to 2 पाई साइन थीटा डी थीटा, सपोज मैं ये इंटीग्रेट करना चाहता हूं, तो दिस फॉल्स इन द कैटेगरी जो हम पढ़ रहे हैं उस कैटेगरी में फॉल करता है, दिस फॉल्स इन द सेम कैटेगरी। सो दिस विल बी इक्वल टू क्लोज्ड इंटीग्रेशन c if I convert it sin theta is 1/2 iota z minus 1/z and d theta is dz by iz. Yes. So this will become closed integration of 1/2 iota one minus 1/z square and dz. Now this is our function fz. Now this is contour integration. So you know we have a unit circle here. Z is equal to 0 is a pole.
I square आएगा ना?
सॉरी, यहाँ पे मैं
Minus
-1/2 लिखने वाला था, -1/2. Okay. So fz is suppose 1 minus 1/z square and z is equal to 0 is a pole. So this is already a Taylor's Lorentz series, already expanded in Lorentz series. So what is b1? 0. Correct? No coefficient of 1/z. So that means the answer is 0. And we know that 0 to 2 pi of sine theta is 0. But this is just to give you an example how it works, how this transformation works. So you have a function in sine theta, cos theta, limit is 0 to 2 pi. You convert it into a complex integration by substituting z is equal to e to the power I theta. That means your contour is now a unit circle centered at origin. Okay? This is how it goes. Next one. So this was just to tell you method क्या है. Let us now solve this. Let us convert it. Contour integration C dz by iz upon a minus b by 2 z plus 1 by z. This will become closed integration C dz by iz upon 2az minus bz square and minus b. बोलो.
Yes, sir.
And upon 2z, z and z this cancels, and you get here minus 2 by ib closed integration C dz upon z square minus 2a by b z plus 1. Is this okay? Now this I want z square minus 2a by bz plus 1 to be converted like this ताकि मैं contour integration लगा पाऊं. And because of this transformation, we have a contour like this, which is a unit circle. Now it will become minus b plus minus under root b square minus 4ac upon 2a. So 2 cancels. Here we have 1. So it will become a by b plus minus right?
A by B plus or minus root of A square minus
1
B
by
square.
b under root of a square minus b square. So what is alpha? Alpha is a by b plus minus a plus root a square minus b square by b and a minus root a square minus b square by b. These are the two roots, alpha and beta. So clearly, if a is greater than b, so clearly alpha is outside this, outside contour, and beta is inside the contour. Alpha is outside the contour and beta is inside the contour. Yes? And also, I want to erase this. This will become minus 2 by IB into 2 pi I into residue. And here we have Z minus alpha, Z minus beta, because we have factorized it. Residue at beta, it will become 1 upon beta minus alpha. If you take beta minus alpha, it will be iota and iota gone, minus 4 pi by b into 1 by beta minus alpha will be minus 2 times under root a square minus b square and 2 and 2. So it will become 2 pi
upon
b and b will also cancel, na?
yes sir.
This will be into b. ये है ना जब माइनस होगा तो
Yes sir.
so it will be 2 pi upon under root of a square minus b square. Please see this and ask me if there is any doubt.
सर
हम्म
सर ये 1 बाई बीटा माइनस अल्फा ये कैसे आ गया?
ये क्या लिखा है मैंने, आप बता सकते हो?
2 पाई आई इंटू रेसिड्यू.
तो ये क्या है? रेसिड्यू. रेसिड्यू, और वो भी बहुत सिंपल रेसिड्यू है. रेसिड्यू एट सिंपल पोल मान लो मुझे लिखना है इसके लिए. फंक्शन इज 1 बाई z माइनस अल्फा, तो कैसे लिखूंगा? लिमिट z टेंडिंग टुवर्ड्स अल्फा, सॉरी z टेंडिंग टुवर्ड बीटा, z माइनस बीटा इनटू फंक्शन 1 अपॉन z माइनस अल्फा z माइनस बीटा. सो z माइनस बीटा कैंसिल हो जाएगा. And when you put the limit z tending towards beta, what you will get? 1 upon beta minus alpha.
ओके सर.
So again it is residue at simple pole. मैंने आपसे बोला था बहुत ढेर सारी सिचुएशन में only this will be used because powers are 1. So residue at simple pole. Anything else? Anything else किसी को?
Sir,
Hmm.
sir, alpha is outside the contour. How?
तो a बड़ा है b से,
Yes, sir.
तो a by b क्या होगा?
एक कोई मतलब इंटीजर होगा.
उसके बारे में कोई आइडिया लग सकता है?
सर फ्रैक्शन तो नहीं होगा मतलब. सब बड़ा है
तो सबसे पहले ये देखो, ये 1 से बड़ा होगा।
अच्छा
ये नहीं समझ सकते कि अगर a बड़ा है b से तो a by b will be greater than 1।
यस सर यस सर यस सर
तो जब greater than 1 में कुछ भी ऐड होगा
तो एक से बड़ा ही होगा
तो 1 से
Yes,
बड़ा
sir.
होगा, इट विल गो आउटसाइड। अगर ये सब बातें इनइक्वालिटी नहीं समझ आती तो a को 5 ले लो और b को 4 ले लो, समझने के लिए। यू विल अंडरस्टैंड।
Yes, sir. I understand, sir.
Take a is equal to 5 and b is equal to 4. So then put it here, put it here. You will see that this will be greater than 1 and this will be less than 1. Okay?
Yes, sir. Got it.
Yeah. Okay. Let us take another question. It is like this. 0 to 2 pi sine square theta upon 5 minus 4 cos theta and d theta. This is the question. So can I write sine square theta is equal to 1 minus cos 2 theta by 2?
Yes, sir.
So it will become integral 0 to 2 pi 1 minus cos 2 theta by 2 5 minus 4 cos theta d theta. Yes.
Yes, sir.
And I can separate it into two problems. One will be half 0 to 2 pi d theta by 5 minus 4 cos theta and minus half 0 to 2 pi cos of 2 theta by 5 minus 4 cos theta d theta. Is this okay? ठीक है भाई? Is that okay?
Yes, sir.
Yes, sir.
So this we have done. This will become 2 pi by root 5 square minus 4 square. This we have to handle. Minus half this integration 0 to 2 pi cos 2 theta by 5 minus 4 cos theta and d theta, right? This we have to handle. Now if I just take care of this integration, let us solve this just by putting z is equal to e to the power I theta. That means z square is e to the power I 2 theta. That means cos 2 theta is real of z square. So it will become half closed integration c z square here real of and dz by iz and upon 5 minus 4 by 2 z plus 1 by z. This is your problem to be solved. यहां तक देखो जरा.
सर
हम्म.
सर जहाँ पे हम लोगों ने साइन स्क्वायर थीटा लिखा है, क्या हम लोग वहाँ पे 1/2i z माइनस 1/z सब्स्टिट्यूट करके थे इस प्रॉब्लम को अप्रोच
कर सकते हो.
सकते थे?
हम्म.
ओके सर.
बट आई अवॉइड डूइंग होल स्क्वायर्स.
ओके सर.
तो इसलिए मैंने होल स्क्वायर को नॉर्मल पावर में कन्वर्ट कर लिया.
यस सर.
तो कितना आ जाएगा यहाँ पे? 2 2 जा 4. हाउ मच यू विल गेट?
So minus 4z square plus 10z minus 4.
रियल ऑफ वन बाई टू आई ना. z यहां से आ जाएगा z स्क्वायर dz अपॉन यहां क्या आएगा? 5z माइनस 2z
2z
स्क्वायर
square minus 2.
प्लस 1 माइनस 1. 5z minus 2z square minus 2, and this will become
Correct है sir.
real of 1 by 2 iota
हाँ सर.
minus 1 by 4 iota. Correct?
हाँ.
Hmm.
सही है सर. यस सर.
Z square minus 5 by 2 z plus 1. इसका फैक्टराइजेशन करना. -2 and -1 by 2. Yes. So it will become z plus 2 and z plus
Half.
1 by 2. Quadratic equation. So this will be inside the contour. So it will be real of -1 by 4 iota into 2 pi I into residue. So this will be gone,
Yes
and
sir.
this will be 1 by 2 whole square simple pole into 2 minus 1 by 2. Correct? So iota gone, 2 2 is 4. So minus pi by 2 into 1 by 4 minus 3 by 2.
Minus 5 by 12.
Hmm?
Minus 5 by 12.
Minus pi by 12. सबका देखना, चेक करना, सही है? So what is the final answer?
सर z की वैल्यू हमने हाफ सब्स्टिट्यूट की है ना रेसिड्यू फाइंड आउट करते टाइम.
पाई बाई 3 आएगा ना यहाँ, माइनस हाफ भी था ना एक, पाई बाई 24। सेवन पाई बाई 24, वो चेक करना जरा।
सर
Sir, it is ZDZ, na sir?
हम्म
Z into DZ it is there. एक Z
का?
तो cancel हो गया था ना sir?
वो सही है।
सर z इज इक्वल टू हाफ पॉइंट आने वाला है ना, तो वो सब्स्टिट्यूट करने के बाद हाफ प्लस हाफ हो जाएगा ना नीचे।
हाफ प्लस हाफ,
z की वैल्यू
what half plus half? So you have two poles, z is equal to -2 and -half, and this will be inside the contour. So when you calculate this, it will be -1 by 4i into 2 pi I into residue will be limit z tending towards -half, z plus half into z square upon z plus 2 z plus half. This will be cancelled, and now put z is equal to -half. So here you will get 1 by 4, and here you will get 2 minus half, which is 3 by 2. Correct? यही लिखा था ना मैंने?
Yes, sir.
What are you saying, भाई?
नो सर, मेरा कंफ्यूजन हुआ था, सॉरी।
Sir, the function is set dz by
Sir, ZDZ, na sir? Because iota Z is in denominator, we have cancelled Z or n Z.
इसके डिनोमिनेटर में z नहीं था?
Yes sir, yes sir.
So final answer क्या है इसका सर?
निकाला तो मैंने। सेम आ रहा है सबका?
Yes, sir.
सेम आ रहा है भाई?
Yes, sir.
ओके। सो क्लैरिटी है मेथड में? कोई डाउट? कोई डाउट हो तो बताओ। If you have any doubt, please you can ask. क्लियर है मेथड कैसे कन्वर्ट किया? और cos 2 थीटा को कैसे कन्वर्ट किया ये भी क्लियर है ना? Because z is e to the power I theta, so z square is e to the power I 2 theta, which is actually cos 2 theta plus I sine 2 theta. So that means if I want to write cos 2 theta, it will be just real of z square in this case. Okay. So similar way we can solve many questions. Like suppose this is the question. 0 to 2 pi cos theta d theta upon 13 minus 12 cos 2 theta. Now how to handle?
This time, sir, we put cos 2 theta as z square. Right?
Hmm?
So cos 2 theta को इस बार z square की फॉर्म में
क्या करेंगे? नहीं पुनीत, तो डिनोमिनेटर में पड़ा हुआ है.
yes sir.
ये तो मिस्टेक करनी नहीं है. आपको सोचना है कि जो आप कर रहे हो क्या उसके बदले वही आंसर आएगा जो आप सोच रहे हो. लाइक
Yes sir.
अगर e टू द पावर ऐसे लिखा होता कि z स्क्वायर इज e to the power I 2 theta like this. So I can say that real of z square is cos 2 theta.
Yes sir.
But it is
Answer
runga real, so will it be same? No.
Question.
no sir.
So we have to manage it very
Answer.
intelligently. So you write it as 2 pi cos theta d theta upon 13 minus 12. What is cos 2 theta? 2 cos
Yes, 1 by
square
2.
theta minus 1. Yes or no?
Yes sir.
भाई cos 2 theta है ना, which is cos square theta minus sin square theta, and this is again 1 minus cos square theta, so it will become 2 cos square theta minus 1. Okay,
Yes sir.
now what it will become? 0 to 2 pi cos theta d theta upon 13 plus 12 कितना होगा? 25
Yes.
minus 24 cos square theta. Now we can convert it into contour integration. See, cos theta is half z plus 1 by z, d theta is dz by iz upon 25 minus 12 z plus 1 by z का not 12, 6 z plus 1 by z का square. Is this okay?
Yes sir. सर एक और स्टेप से छोटा सा डाउट था. क्या मैं cos 2 थीटा को z स्क्वायर प्लस 1 बाई z स्क्वायर की फॉर्म में लिख सकता हूँ, जैसे मैं cos थीटा को रिड्यूस करता हूँ कॉम्प्लेक्स नंबर से? ओके सर.
तो ऐसे ही समझ लो 1 by z स्क्वायर क्या होगा?
e to the power minus I 2 थीटा.
So cos 2 theta will become
1/2 z square plus 1 by z square.
yes, it will become like this.
Yes, sir. Yes.
I can use it there actually. So I can make it little, if you don't want to go this way, I can make it little simpler by just putting this. So this I will write as contour integration. I will this write as z. I will write real here, okay? Z is e to the power I theta. It will give me cos theta. And this will become dz by iz. And upon this will become 13 minus 12. And please see here, ये सबको समझ आ रहा है ये चीज? If you write z square as e to the power I 2 theta, you write 1 by z square as e to the power minus I 2 theta. This is cos 2 theta plus I sin 2 theta, and this is cos 2 theta minus I sin 2 theta. And if you want to add this, it will give you cos 2 theta. And it will become 1 by 2 z square plus 1 by z square. यहाँ से z कैंसिल हो जाएगा. And this will become 6. This I hope you understood. And finally, this will become कितना हो जाएगा? Real of 1 by iota contour integration C dz by, यहाँ पे ध्यान से लिखना, 13 z square
Yes, sir.
minus 6 z to the power 4 minus 6. Is this correct? By z square. So it will become z square.
Yes, sir.
Now take real of minus 1 by 6 iota close integral C z square dz by z to the power 4 minus 13 by 6 z square plus 1. Okay? This is your quadratic equation. Write it as t square minus 13 by 6t plus 1 and factorize this. Tell me what you will get.
Sir, 3/2.
2 by 3.
Yes, sir.
माइनस में ना?
नहीं सर, दोनों प्लस में.
दोनों प्लस है तो जुड़ के minus 13 by 6 कैसे हो जाएगा?
हाँ सर, एक सेकंड से चेक करता हूँ.
इसको सम तो यही होना चाहिए ना, 9 minus 4, सही तो है?
Yes,
So
sir.
it is t plus 3 by 2 and t plus 2 by 3 and t is
Z square.
z square. एक बार और भी लोग चेक करो जरा, रूट्स जो है और द रूट्स ओके?
बट सर वैल्यू में नेगेटिव नहीं अभी ला पा, एक बार चेक करूंगा।
सर रूट्स की वैल्यू नेगेटिव नहीं आ रही है।
पॉजिटिव आ रही है?
हाँ जी।
यस सर।
यहाँ पर?
यस सर।
हाँ जी सर, यहाँ पर।
ठीक है। सो दिस विल बिकम माइनस ना?
यस सर, यस सर, तब भी वैलिड रहेगा सर।
Okay, so let me put it here now. What it will become? Z, इसकी जगह क्या आ जाएगा? Z plus root 3 by 2, Z minus root 3 by 2, Z plus root 2 by 3, Z minus root 2 by 3. So root 3 by 2 I think greater than 1 होगा?
यस सर।
हम्म?
यस सर।
और ये लेस, सो इसको ऐसे ही रहने दे, फिर इसकी जरूरत ही नहीं पड़ रही है ना। Z square minus 3 by 2. These two are under, so calculate the residue. So first residue is at Z is equal to root 2 by 3. ये क्या बन जाएगा? It will become Z minus root 2 by 3 into Z square upon Z square minus 3 by 2, Z plus root 2 by 3, Z minus root 2 by 3. This will cancel and limit Z tending towards root 2 by 3. So what will be this? Here we will get 2 by 3 upon here 2 by 3 minus 3 by 2, and here 2 times root 2 by 3. कितना आ जाएगा? This will become 1 by 2 root 2 by 3 by 4 minus 9 कितना होगा? minus 5 by 6. So what is this? Minus 3 by 5 root 2 by 3. Okay?
यस सर।
आ रहा है किसी और का भी? और अब इस पे निकालो, इस बार z प्लस रूट 2 by 3 से मल्टीप्लाई करो फॉर सिंपल पोल। . यहाँ पे z प्लस आएगा, इस बार z प्लस से कैंसिल हो जाएगा, z माइनस वाला बचेगा, तो कितना आ जाएगा? स्क्वायर वाले पे तो फर्क ही नहीं पड़ेगा, बस यहाँ माइनस आ जाएगा ना।
यस सर।
जो चीज माइनस, जो चीज 2 टाइम्स थी वो -2 टाइम्स हो जाएगी। तो हाउ मच वी विल गेट? We'll get the second residue as 3/5
प्लस
root
2/3
2/3.
यस सर।
So answer will be real of -1/6i into 2 pi I into sum of residue, which is 0. So answer will be 0. एक बार चेक करना इसको, कोई डाउट है तो बताओ जरा अभी, अगर कोई डाउट है तो। फिर से रेसिड्यू एट सिंपल पोल यूज हो रहा है। व्हाट वी आर यूजिंग? रेसिड्यू एट सिंपल पोल। रेसिड्यू एट सिंपल पोल समझ आ रहा है सबको? So every time I am using this limit z tending towards z0, z minus z0 and fz. That's it. तो ये 0 से 2 पाई वाला केस क्लियर है?
सर।
यस सर।
चलो फिर, if you have any doubt you can ask, otherwise we'll continue next class. Yes? Okay. Okay then, thank you. Good night.
Thank you, sir.
थैंक यू सर।
थैंक यू
Okay.
सर। थैंक यू।